Video number 22, Econometrics in Practice Using Data and R. After this video, I will do a complete comprehensive workshop on our research question whether class size reduction lead to improvement in test score or not, or how much it leads to improve in test score. At the moment, we are going to discuss interaction between independent variables. You can have independent variable binary, you can have independent variable interaction binary and continuous and continuous. So you have three cases in binary interaction. There is change only in intercepts. In binary continuous, you will have a slope change, and in continuous you have same intercept, different slopes. So let's see that. So let me take the very first one, binary. Why do we need interaction? As in one of the video I have explained that beta 1 is effect of d1 on y holding the effect of d2 constant. Holding the effect of d2 constant means eliminating, parceling out, netting out, purging out the effect of d2 from d1 as well as from yi. So for example, if I want to see the impact of graduation on earning, so what we have to do? We say d1 is equal to 1 if graduate and is 0 if not. This is for graduate, this is for undergrad. No, d2 is, let's say, male female, sex male female. No, when we see the effect of d1, that is effect of graduate on y, there is both male and female are excluded from it. And when we see the effect of male or female, then this graduate effect is not included. I am interested what is impact of being a male and graduate, being a female and graduate, being a male and non-graduate, being a female and non-graduate. So for that, what we have to do? D1, D2, D1 into D2. We are introducing interaction term here. Why do we do this? Look here. Let's see the next slide. Or we can have a blank slide here. Yi equal to beta 1 plus beta naught, beta 1, D1, beta 2, d2, beta 3, d1 into d2 plus uy. So what do we say? When d1 is 1, d2 is 0, so you will have only y equal to beta naught. If both 0, means undergrad 0, female 0, it's beta naught. Male, graduate and female, it means y is equal to beta naught plus beta 1. This will be 0 because d2 is 0. Male, graduate and male, undergraduate and male, that will be equal to beta naught plus beta 2. As d1 is basically undergraduate, so d1 is 0, so this interact. And male and graduates, so this is 1, and this one will be 1, so you will have y equal to beta naught plus beta 1 plus beta 2 plus beta 3. So you have this one is if undergraduate and female, graduate and female. Okay, this one is male and undergraduate, and this one is male and graduate. So this is possible only if you have interaction term, because otherwise if this term is not there, D2 is eliminated, so it means graduate. In fact, we don't know whether male or female. So that's how we are what we were talking about. Now you have research question whether class size reduction leads to increase in test score or not. So you have two binary variables here. If class size is greater than or equal to 21, less than 20, 0. Percentage English learners greater than or equal to 10, less than 10, to 0, 1, and you can have these coefficients measured as we have discussed in our previous slide. If you have one binary variable, one continuous variable, so now they will have an interaction like this one. So when D1 is 0, so it means it's beta naught plus beta 2, this one will be 0. When D1 will be 1, D1 will be 1, so this is 1, so intercept will be beta naught plus beta 1 instead of just beta naught. And this slope, when D1 is 0, slope is only beta 2. When D1 is 1, not only intercept will change, but slope coefficient will be beta 2 times plus beta 3 xi. D1 is 1. So you have slope and intercept both different when you have one binary and another one continuous and their interaction is there. So that's what. Look here. So this is where you have both binary. Only difference is in, this one is where you have a slope in both cases is beta naught, beta 1, but intercepts are different. In this case, you have slopes different, intercepts different. In this case, you have slopes and intercepts, intercepts and slopes are different. So you can have these three cases. And another last one is that interaction of continuous with continuous. For that you have to do calculation point by point, because you have x1, x2, x1 into x2. So you will say if x1 is 20, x2 is 10, then x1, x2, what will be their product? Similarly, x1 is 21, x2 is 11. What will be x1 into x2? So you will have continuous and continuous. This one is binary and continuous, and similarly you can have a continuous and continuous one. This one is the interaction. In this case, intercept will be same. In this case, intercept will remain same, beta naught, but slopes will be different. So it will be like this. That's how we interpret change in y due to change in x. Change in y due to change in x2 to a slope. The slope will be different at different points. So you will say if percentage English learner 0, if percentage English learner 20%, if student teacher ratio is 20, student teacher ratio is 18. So you have to do it point by point. So that's how you can understand. Please, time and again, I'm asking you that if you want to get maximum out of these videos, follow Stock and Watson book. It's chapter 8. We are going to finish this chapter 8 and we are going to almost complete our first research question, whether test score leads student teacher ratio reduction leads to improvement in test score or not. We have discussed from video number 1 to video number 22. In my next video, I will demonstrate the comprehensive workshop using Stata, and I will put a link on RPubs how to do it in R. So non-linear effects on test score of the student teacher ratio, I leave it for some other time. And what will be my next video? That my next video will be to produce these 7 columns and to answer the question whether class size reduction leads to improvement in test score. Other variables, all these variables are included so that this student teacher ratio effect can be measured correctly. Thank you for watching. Take care.